Section 9.4, product to sum and sum to product formulas. We're continuing to build out our tool belt for dealing with trig functions. And next up, we're going to deal with, okay, what if we have a product of two sine functions or two cosine functions, or a sine and a cosine? Okay, how are we going to rewrite that as not a product, as sometimes we'll have to do? Well, we have these nice formulas for it. The derivation is pretty straightforward. Remember these formulas from a few sections back. These are the sum and difference formulas for cosine. That's what we're looking at here. And what we're going to do is we're going to just, take these two equations, these two identities, and we're just going to add them straight down. And something nice is going to happen because notice these terms right here, okay? The negative sine x1 sine x2 and the positive sine x1 sine of x2. Those are going to cancel each other out because they're equal and opposite. So when we add these together, here's what we get. We get cosine x1 plus x2 plus cosine x1 minus x2. And this will be equal to, and like we said, these terms will cancel out and we'll just be left with the sum of these terms right here. And that is cosine x1 times cosine x2 plus, same thing, cosine x1 cosine x2. All right, those two terms are identical, so we could rewrite this on the right-hand side as just 2 times cosine x1 times cosine x2. Okay, and same thing over here. Nothing changes on this side this time. All right, and then we're trying to find a formula to rewrite a product of two cosine, cosine evaluated at x1 times cosine evaluated at x2. So the last step is I will just divide both sides by 2. And that gives us our formula. Cosine x1 plus x2 times cosine x1 minus x2. And we'll have that factor of 1/2 out in front. I'll write it like this. After dividing by 2. And that will be equivalent. Sorry, plus sign in the middle there. That'll be equivalent to the product of cosine x1 times cosine of x2. All right, so there's our formula, and this is just one of them. The derivations for the other two are very similar. You could probably figure out how to derive those on your own. I encourage you to think about that a little bit. But here they are. Here are the 3 product to sum formulas that we're focusing on here. Okay, so in example 1, suppose we wanted to rewrite this product. We have cosine 5 theta times cosine of 2 theta as a sum. Well, now we have these super convenient formulas to do this for us. We just have to decide which formula we're using and what is our x1, what is our x2. So this is a product of 2 cosine functions, so I'll be using this second formula right here. And I might point out, we could say x1 is 5 theta, and let's have x2 be 2 theta. Okay, so now let's apply this theorem. We want cosine of 5 theta times cosine of 2 theta, and we're going to apply that formula to rewrite this as a sum. So here we go, 1/2 times, in the inside of the brackets, we'll have cosine of x1 minus x2. So that'll be 5 theta minus 2 theta. That's the difference inside of a cosine, plus cosine of x1 plus x2. So that'll be 5 theta plus 2 theta. All right, now we just want to simplify a little bit. This will become cosine of 3 theta plus cosine of, adding those together, 7 theta. All right, and then just to have this as a proper sum, we can distribute that 1/2. So 1/2 cosine 3 theta plus 1/2 cosine of 7 theta. So this is an equivalent form for cosine 5 theta times cosine 2 theta, just expressed as a sum using that second product to sum formula. All right, so pretty straightforward. Just decide what x1 and x2 are, use the correct formula, and plug and chug. All right, example 2. This is another instance where these formulas can be really helpful. We want to evaluate this product sine of pi over 4 times sine of pi over 12. Now, as a first attempt at simplifying this and evaluating this, I might think, oh, sine of pi over 4, that's root 2 over 2, and then I'll just multiply by whatever this is and get my answer. And that's fine. You could do that if you happen to know what sine of pi over 12 is. But pi over 12, as we've seen a few times in this chapter, it's like we don't really have the unit circle memorized up to pi over 12. I don't really know how to work with 15-degree angles in right triangles, so it's not a familiar angle to me. So if I can use an identity to rewrite this in a friendlier kind of form, I might do that. So let's see what happens if we rewrite this using the product to sum. So I want to rewrite this as a sum. Now here's our formula up here for sine. Okay, if we have sine of x1 times sine of x2, it's going to be 1/2 cosine the difference minus cosine of the sum. All right, so this will be 1/2 times cosine of the difference, pi over 4 minus pi over 12, minus cosine of the sum, pi over 4 plus pi over 12. All right, this is just my x1 and this is my x2. Now let's simplify this and see if it's helpful. Now adding pi over 4 and pi over 12, I'll do this in a couple steps. I'll have to get common denominators. I'll multiply top and bottom of pi over 4 by 3, so 3 pi over 12. All right, just getting common denominators. Same thing over here. I'll multiply pi over 4 again, top and bottom by 3, so then I'll get 3 pi over 12, and I'll have common denominators for that addition. And then I'll have cosine of 2 pi over 12 minus cosine of 4 pi over 12. And I'm liking how things are looking. I'm just trying to get that to simplify that 12 in the denominator. I would much rather that be either a 1, 2, 3, 4, or 6. Because now that I have pi over 6 here, I know what cosine of pi over 6 is. I can at least use the unit circle to find that out. And over here I'll have cosine of 4 pi over 12. This is pi over 3. Sorry, I wrote that as 1/3. It should be 1/2. Okay. Pi over 6 and pi over 3. You could use the unit circle. How about let's do right triangles this time, just to kind of stay in practice with each of these. Pi over 6, that is 30 degrees. So remember this triangle, 30, 60, 90. 1, 2, and root 3. Short side is 1, hypotenuse is 2. Long side is root 3, right? This is just our 30, 60, 90 triangle. Okay, pi over 6 is this angle right here. Cosine is adjacent over hypotenuse, right? So cosine of pi over 6, that's just cosine of 30 degrees, which is adjacent over hypotenuse, which in this case is root 3 over 2. Okay, so I'll put in root 3 over 2 for that one. And okay, I could actually use the same triangle to find cosine of pi over 3, because pi over 3 is just 60 degrees. So cosine of pi over 3 is going to be, again, adjacent over hypotenuse. It'll be 1/2. You also could have done that using the unit circle. I'm fine with whatever you like. Okay, and simplifying 1/2 times root 3 minus 1 over 2, just combining those fractions. Root 3 minus 1 over 4 is that simplified down. And that's great. I can leave my answer as that. You could put it into a calculator, but in math we tend to prefer the exact answer rather than the decimal approximation. Root 3 is an irrational number, so you'll get a long decimal you'll have to round. I would prefer to just answer it like this, so there we go. All right, let's keep moving here. Now there are other times where rather than going from a product to a sum, we might want to go from a sum to a product. And we have formulas for that as well. So here they are right here. I won't talk about the derivations. If you want to know about them, you can ask me in class. So here they are, difference of two signs. So sine of x1, or sorry, sum and difference. Sine of x1 plus sine of x2, sine of x1 minus sine of x2. Same formulas for cosine. And here are the formulas over here. All right. Let's see if we can apply these to help us out in example 3. We're looking at cosine of 5 pi over 12 plus cosine of pi over 12. Okay, again, seeing the 12s in the denominator, that's a pretty good indicator that we'll want to use some kind of identity here. And the sum to product is just, the most obvious one since we're looking at a sum of two cosine functions. So which of these 4 formulas will we use? Well, we've got 2 cosines and we've got a plus sign in the middle. So I'm thinking of using this third formula here. And I'll label my x1 and my x2 just to make sure I don't confuse myself, write something in the wrong place. And let's just plug it into the formula. So 2 times cosine of x1 plus x2 over 2. So 5 pi over 12 plus pi over 12 divided by 2, like that. Times cosine of now the difference, 5 pi over 12 minus pi over 12. Whole thing divided by 2. So we've got fractions inside of fractions, so I'm always extra careful when I have like nested division like that. But we'll start by simplifying the numerator, add those together, we get 6 pi over 12, which simplifies to pi over 2, all over 2. So that's nice. This next one, 5 pi over 12 minus pi over 12, that's 4 pi over 12, which simplifies to pi over 3, divided by 2. All right, and then pi over 2 divided by 2, You could do the thing where you turn the main fraction bar into a division sign, then multiply by the reciprocal. Or sometimes people like to do this, multiply top and bottom by 1/2. Right, that cancels out the 2 in the denominator, and then we're left with pi over 4. This one simplifies to pi over 6. Okay, and at this point I'm happy. The formula enabled me to get these inputs to the cosine to be values that I'm used to working with. So cosine of pi over 4, that is root 2 over 2. All right, and cosine of pi over 6, I think we just found that in the last example. That's root 3 over 2. If you're doing all your homework and getting lots of practice with this, you might just have cosine of pi over 6 memorized by now. Okay, and we'll simplify a little bit. We can multiply together, so root 2 times root 3, we can just write that as root 6, and we'll just have root 6 over 2 when all the dust settles. Okay. And that's fine. That's, totally simplified. I can just box that up and submit that as my answer for this one. Okay, so that's it. Not a particularly long section here, just a few more identities that we can work with. And moving into 9.5, shifting gears a little bit, solving trigonometric equations. This is a really cool section. I'm looking forward to this one. So I will see you in the next video.